Hello everyone. Today we are going to see the project name called Smart IoT ML for non-invasive disease prediction using real-time methods. So, tuberculosis or TB is one of the most serious repository disease, especially in developing rural regions where access to advanced medical facilities is limited. Although TB can be treated effectively, the major challenge lies in early detection. Traditional diagnostic methods such as chest x-rays and molecular testing are accurate, but they are time consuming, expensive, and infrastructure dependent. Because of this, many patients experience delayed diagnosis, which increases disease transmission and health risks. One of the earliest and most common symptoms of TB is coughing. Along with the cough, abnormal vital signs such as high body temperature, low oxygen, irregular heart rate, and poor air quality exposure, providing strong indicators of respiratory illness. However, in existing systems, cough analysis and vital monitoring are treated separately and mostly rely on manual observation. To address this gap, this project proposes an AI-enabled non-invasive screening system that integrates deep learning based cough detection with IoT based real time vital monitoring. The system uses a convolutional neural network CNN trained on MFCC audio features to automatically detect cough sounds. At the same time, vital parameters such as temperature, SpO2, heart rate, and gas levels are collected through IoT sensors. By combining both audio and psychological data using a fusion approach, the system classifies the user as normal, cough detected, or TB risk. The entire solution is implemented as a Flask based web application, making it low cost, portable, and suitable for rural clinics, mobile health camps, and remote monitoring. So this is our block diagram. So our system starts with the user or patient who provides two types of inputs, cough audio, psychological data. First, I will explain the audio part. First, the user coughs near a microphone and the audio input block captures a short duration sound signal. This raw audio often contains background noise, so it is passed to the audio pre-processing and noise reduction block where unwanted environmental sounds are be removed using noise reduction techniques. Next, the clean audio signal is sent to the MFCC feature extraction block. Here, frequency coefficients are extracted to represent the frequency characteristics of the cough sound in a compact numerical form. These MFCC features are then fed into the CNN model for cough detection. They trained on the CNN analysis and the features and learns patterns that cough sounds from normal sounds. Based on this analysis, this prediction output block produces a result indicating whether a cough is detected or not. Now we'll see the IoT sensor path. So in the IoT sensors continuously measures body temperature, SpO2, heart rate, and gas concentration. These values are transformed to the backend system. So the Flash backend blocks fetches this data from the cloud API and stores it in a local database. So the VTILS classification block then evaluate each parameter using predefined threshold values to classify them as a normal or abnormal. After this, the table risk decision fusion logic combines the cough detection result with the classified vital signs. If cough is detected along with the abnormal vitals, such as high temperature or low SpO2, the system identifies a TB risk. If only cough is present, it is marked as a cough detection, and if everything is normal, the result is normal. So finally, all results are displayed on the web dashboard where users or healthcare workers can view predictions, live details, and system decisions in real time. So this is our training code. First, we are importing all the libraries, then we are setting the data about sample rate, duration in the audio, how much duration it should have to take, and the MFC features rate. So here we are extracting features from the file path with the sample rate and along with the MFCC features. We are extracting features from the audio. Further, we are using Librosa after extracting the features. So here we are setting the correct path. So here we are loading our data set. So our audio file should be in these five, six formats only. Then only it will accept. Once if you load the data set means then it will be pre-processed like a noise. If any noise is there means those things will be removed and it's to extract the features. So we are using a label encoder. Why we use the label encoder means like to converting strings into bytecodes. So here we are splitting our data set. So 20% for testing and 80% for training purpose. This is our model. So we are using CNN model. So with the CNN model, we have trained our data set with the epochs of 50 and batch size of 80. So once after training, our model will be saved in the name of cough detector, CNN final, and along with the label encoder. So this is our app code. So we are using Flask for creating a web page. So here we are loading our model and our encoder also. So this is the link. From this link only we are getting the data through our web. Here we are creating our database. So our database name is data.db. So here we are storing the data like ID, temperature, SpO2, heart rate, gas. These data will be stored. So these are the helper functions. These things will be helping for us to store the data in the database. So once if you click the live button means then audio will be captured. After that audio will be from the audio we extracted the features and then we'll reduce the noise, background noise and will pre-process that thing. And then based on that we'll classify whether it's predicted cough or not. So these are the classified vital signs. So if temperature is less than 96 means will display low or else it is high. For the SpO2 heart rate also like that only. So these are all our routers, home router, live data, database, delete, predict. We have four routers. So in the live data means if you click the live data means then in our web page it will be show 10 records, latest 10 records from the link which is so database means in the database it will display all the records which are all fetched through the link. So we have on delete button also. If you click the delete button means then all records will be deleted. So this is our prediction page. So in the predicted page means so once if the audio capture means then it will be pre-processed and extracting the features. After that it will give to our model. So our model will predict whether it is a cough or normal and then after we'll integrate the TB logic based on the vital signs. If so, once after the prediction, then also it will be stored in our database. In our database, we'll store in the two separate pods. One pod for what all the data we are getting from the link, those data will be stored in a separate pod, and which are we are predicting that thing will be stored in a separate pod inside the single web page only. Once if you run means then it will give one link. We need to follow that link. So this is our dashboard, real-time health and cough detection. So if you click live data means then the live values will be displayed here. So as of now the temperature is 85, SpO2 is 98, heart rate is 85 and gas is 500. So if you click predicted and then if your options means then it will be displayed only normal. So it's listening for first 5 seconds and then 5 seconds it will go for 3 seconds for the prediction purpose. So it's predicting normal with the confidence of 99%. And temperature, SpO2, heart rate, gas status are all normal and temperature only low it's showing. So TB status is no TB. So now we'll change the live values, then we'll predict with the cough audio. So now our data is updated, like temperature is showing 100, SpO2 58, heart rate 70, and gas is 1000. Now we'll predict with the cough audio. So it's predicted it is a cough and confidence of 94% and temperature is normal temperature, SpO2 low, heart rate normal and gas status is high. So based on this, it's predicting possible of TB. Why it's predicting possible of TB means in our code we have defined something like if a temperature status high or SpO2 status low means then it will be displayed as a possible of TB. Whether if the temperature status high and along with the SpO2 status is low means then we have confirmed the TB is detected. If one is high or temperature is high or SpO2 is low, like with this, if anyone is detected means then it is a possible of TB. Now, if you click the live data, means then here showing temperature is 120 before it's 100 only. So SpO2 and heart rate case are remaining same only. Now we'll predict. So it's predicted cough with the confidence of 99 percentage and the temperature status is high and SpO2 is low. Heart rate normal, gas is high. So if the temperature and SpO2 both are high and now low means then we have confirmed that TB is detected. Whether if any one of this is high or low means then it is a predicted of, like possible of TB, or else if, whether it is not a cough means then it will be displayed as normal only. This is our database. Before only I told that in our database we had stored two types of data. So the first it's showing all the values which we got from the link. So this is our predictions though. So here it showed the normal cough, those things. So if you click the delete out button means then our database will be clear.